Hi, welcome. In this demo, we are going to look at how to set up disaster recovery using SWIFT between two Oracle regions. And in this case, though the regions are within the same tenancy, you can apply the same steps for different regions across two different tenancy to set up the disaster recovery using the same steps. So let's get started. So let's first look at source clusters. So they are running in the US East region and they are part of the same tenancy. They're called OKE demo 1 and 2. And there is no native dashboard or the object browsing through Oracle native dashboard. So I have set up the Kubernetes dashboard for each of them. So here's the first Kubernetes dashboard for the first cluster. And you can see there are a bunch of namespaces. The one we will be replicating is this Blogger WordPress. This is the Blogger application, using the WordPress as the front end and the MariaDB as the back end. And let's browse quickly through the app. You can see it has a bunch of like one deployment, bunch of ports for both deployment and stateful set, and then replica set as well. Also, you can see that it has a bunch of persistent volumes, like one each for both front end and the back end, and they are using the Oracle block storage. Let's now also see if there is a config map. Yes, there are two, and there are a bunch of secret objects as well. You can see that here. Let's connect to the app and just look around. So we should be able to see a few dummy blogs. So you can see one here, and there is like a few comments, etc. And I can connect basically as a admin to this application. If I connect, it's gonna give me a few push. For example, here's the post we saw that is live right now. This is a dummy blog. We'll not do any change right now. We'll do that as part of Delta Sync demonstration. Let's close this app. Now let's look at the second dashboard. Let me log in here. Okay, and you can see it also has bunch of namespaces. Let's browse through them. And this is the one application which will replicate. This is stateless app. The earlier one was mix. It had deployment as well as stateful set, but they were using both volumes. Of course, it has the state. So overall, the application was stateful, while this is the stateless app. Now, this is an nginx based application that's just serving one static page. And this is just for the demonstration. So let me show the workloads of this app by connecting to that namespace. You'll see it has like one deployment and two pods and replica set created as part of that. And of course, there will be a service which will be to expose the application to the outside world. So let's connect to that as well and just look at the application. So static application web page is just coming up fine, and it does fetch some data using Kubernetes APIs just to show some activity from the application. You can see it's running as the nginx application. Let's close that app. Now let's move to the Swift server. So this is running as a VM in demo lab, which is connecting to both uh, regions to public internet connectivity. But in real world, you will have this running into your DR region. You will launch this either from the marketplace or you'll install this. And as part of both process, you'll generally set initial password for the admin user within Swift, and then you will create multiple users. Let me log in. So I have set that up already. So I'll log in. I'm in, and there are like a bunch of older applications there. So let me go to the clusters, and you will see three clusters which are already Discord. The Discord cluster will go here. You will put a name, and you'll tell like where it's located. For example, in case of Oracle, it's like what's the real name, which we saw in the Oracle native dashboard, and then of course few Oracle Cloud credentials, including the API key and region compartment. You'll also select like where it's running, and that's all. So once you do that, it's just gonna go ahead and discover. And that's something will look like this. If I rediscover at this stage, it's gonna just take 2 or 3 seconds. It's gonna connect and collect all the metadata of the clusters. Okay, so all the clusters are discovered now from both sides. Now let's actually look at target cluster 2 just to show. Now it's running here in the Phoenix region, US West. And here's the native dashboard for that. Let me log in again to the target dashboard as well. And you can see like it just has all the native namespaces except the Kubernetes dashboard, which is this specific app which we are looking at that provides the dashboard for accessing all the Kubernetes YAMLs and objects. Okay, all right. So let's do this. So we'll set up a DR policy now, which replicates both our production clusters to the same DR clusters. Now, in real world, that mapping could be you have one-to-one mapping between your clusters, or you could do consolidation like we are doing in this demo, or you could also do like splitting where one cluster is synced to like a multiple target clusters. All are supported. For simplicity, I'm just syncing both of those to the same target or DR cluster now. And also DR cluster could be dynamically provisioned. In this case, I have it pre-provisioned and discovered here. So before we create a DR policy, I'm gonna go ahead and create my storage pool where the data will be backed up. So I'm gonna give it a name like a SWIFT storage pool and select a device that's part of will be this pool. And this is the block volume attached to the SWIFT VM already. All right. So we have SWIFT storage pool created, and you can see there's no backup created, and you can see all the disk, etc. allocated here. Now let's go ahead and create a DR policy here. I'll call it DRP 30 minutes, which syncs basically backs up and restores every 30 minutes. So every time it syncs or backs up, it's going to create incremental backup. I'll give by frequency and 30 minutes. And restore will be right after the backup is done. You can specify the email alert as well, like your email, where it will alert every time it backs up or restore something, or even if something goes wrong, like it will give you everything you would want to know on email. At the policy level, it's just a scheduling config, but you can also do pre-post scripts. When you fail over this policy, it's gonna use those, and also how many max parallel syncs it can do, because single policy can drive multiple syncs across multiple source and target clusters. So this configuration comes handy, and then you'll also specify like how many backups you want to keep. So I'm gonna specify, okay, keep my 5 backups, and the frequency of each backup will be 30 minutes because that's what we are specifying as the sync frequency. Let's create the policy. At this stage, it's just the scheduling config. The policy is not active. Now, what we'll do is we'll apply this policy to both the applications. So they start syncing every 30 minutes. So every 30 minutes, we'll create incremental backup into SIP storage and then immediately restore to the DR cluster as well. And we'll be able to test that after initial replication. The first sync will be full sync, subsequent syncs will be delta sync. So let me do the policy apply now. And we'll ask it to start immediately. So as soon as we start configuring, so I have two configurations here for two apps. And we do have a script where instead of configuring this policy per application or per namespace, etc., you can just create like a CSV where you tell all the clusters you want backed up and few configurations or the options. And we have a script that will put those or map those into the policy configuration. So later you just come here to the dashboard and failover policy to do the failover or do the fallback. So you don't need to do those manually. But this is essentially configuration. And shortly in upcoming release, you'll have the ability to upload the CSV into the dashboard as well. It's the same configuration that script is also enabling that we are doing here. And it's a very straightforward configuration. For example, for my source cluster, the first cluster, OK prod 1, I'm selecting my DR cluster as OK DR. And the first application is our Blogger app that will replicate it. It will create this namespace on the target. When it restores, I can choose which storage class those volumes go as. I'm gonna keep that as the Oracle block volume. That's the preferred one on the Oracle side, and I'm gonna select all objects. And you can do the select to sync as well. Like for example, instead of selecting entire namespace, if you know like how your application is configured, you can select a particular deployment or a particular stateful set, and it's gonna sync everything, all the dependencies for that. For simplicity, let's sync everything. And this is just the transient pod configuration where SWIFT will connect and use that during sync. And also the transient registry I'm going to use is one I have for the upload, transient upload, and I'm reusing that same site. Ideally, you'll have this as OCIR and configured one time. And let's also give the backup as some interesting, useful name. So this will be blogger backup. This is the logical entity created in SWIFT to which all the backups are tried, incremental backups too, which you can use later to do explicit restores outside of fallback. All right, so we selected our source cluster, we selected the storage pool, we selected what the volumes will look like, and then the application name as well, and we asked it to do all the objects, and let's select the region for the fallback. So when you fall back, where those volumes will go, that's the configuration we are selecting. That's all. So we are good. So it's gonna kick off immediately like a backup and restore for this, which is fine. The policy is active. Let me apply it again for the second application now. I'm gonna do the similar configuration. So I'm gonna select my second production cluster to the same DR cluster. And this time namespace is demo UI. And I'll retain the same namespace, the target, though you can change that. I'm gonna select all objects, do the something similar here, though this is stateless app, so it doesn't really have any data there. And similar config, this one too. All right, so we have all the configuration done now. Let's cross check everything looks good. We just need to also specify the name. So this is Swift UI stuffs. That's the application, the dummy application we have. All right. So also one more thing, like you can also specify the levels. So earlier application went into level 0. We are putting that into the same level. So if we want this to be synced in different level, you can specify that. The apps that are syncing in one level are batch synced together. Like their syncs will run in parallel, while the different levels are serialized. Like one level will run after the other. You can control, of course, like how many parallel syncs you can run through the OC config, which we saw earlier. Now let's kick this up as well. Pulse is active now. We can see that it already started doing the backups. Our first app, and we'll see the second app too. So here we can see actually this was stateless app, so the backup was instantly completed. The second backup is still running because it has a good chunk of data, so it's backing that up. The source application will remain into production. There is no impact. And same time, since first application backup or which is running on cluster 2 is complete, which is our stateless app, it started restoring that on the target. All right, so the restore is running now for both the apps. The backup is completed, and you can actually go and see the checkpoints here. The backup will show the nice check. It backed up, it will also show the nice summary, and then of course the synced volume summary as well, like all the volumes. Right? Let's go back. Restore for one of the apps is complete. This is initial replication. So now it will sync after 30 minutes. We'll take a look at now the target cluster once this second restore completes as well. So our second application restore is about to finish, which is our Blogger application. The other one already finished. Give it a minute and then it should be ready in the target after the initial restore. So application should be up. We should be able to verify. All right. So both restores finished. So we have initial backup and restore done. And let's look at the target cluster now, which is our DR cluster. So we can already see that two new namespaces popped up here, which are just now created. So one is our application from the cluster two, and this is the application from. Let's take a look at one by one. Let's select the first app, which is our WordPress, and let's look at all the workloads for it. So you can see there is one deployment stateful state and the bunch of pods, which is two, one each for the deployment and stateful state. Then all the services, content maps, everything restored for it, even secrets. Right. Then also let's look at the persistent volume. You can see both volumes are restored with all the labels and they were mapped to the correct storage class that we expect to do. Let's take a look at the actual application. Let's go to the service and let's connect to the service endpoint. And you can see the application is up. Just look at the test blog as well. You can see that it's coming up fine. Test comments, etc. there. And let's also try login to its admin interface. And we can see that like all the posts we created, etc. Basically, all the app is working fine. The data is also there, as expected. Now, let's take a look at the second app, so which is our nginx based application. And let's first look at the workloads. So you can see that it had one deployment, two pods, and one replica set each. And there was one config map, which is also there. There's no persistent volume here. So let's again go to the service and then connect to the app. And you can see that like the app is coming up fine. It's now running into the new environment. And you can already see that like, from the details as well, that it's working perfectly fine. Now, let's do one thing. So let's go back and do some changes in our source application, in Blogger application, and we'll let Delta Sync copy over the Delta. Let's go to the first cluster, production cluster. We can see the app is already up. I'm going to connect it back there again and connect to its admin interface. And let's create a one dummy post. So let's call it Delta Sync test demo. Let's publish it. Now, if I go back and in post, I can already see this. And I'll actually go back to the app's regular interface and I'll just connect again to the same endpoint. And we can see that our page is live. We can actually see the contents, there's no comments, etc. So all looks good. So Delta is there. Now we'll go back to SIP and wait for next Delta sync to kick off, and that will carry over the Delta changes from source app to the target app without disrupting anything on the source. And while that sync kicks off, let's take a look at backups for a moment. So we can see now the names we gave, it created backups with those names. Now if you click here, so you'll see the incremental backups created as well. And we can have a window and this can be pushed to the object storage as well optionally. These are right now stored in the SIP storage, in the SIP storage pool. that we attached to the Swift VM. Similarly, this is the Blogger application, and you can see this. And you should be able to restore this. Like if you select this, so you can directly select like a cluster and it to restore that. That's just for testing. Like it's very handy. So let's go back and let's wait for the next Delta sync to kick off. All right. So moving fast forward, the next sync window triggered. We configured it to run every 30 minutes. So next scheduled syncs and the backup for again, the stateless app completed pretty quickly because there's no data, but it did the new backup and it started backup for our Blogger application. So this should move now the Delta sync changes. And since the backup for the stateless app is done, it also started restore for it. And again, that should be pretty quick because it doesn't really have data. So it should just Delta sync the YAML manifest. And for the other one, the backup is doing the Delta sync now. Going fast forward again, so our Delta syncs completed. And these were syncs scheduled by the policy for the next iteration as we asked it to do run sync every 30 minutes. And as you can see here, both applications were backed up as well as restored. And this was Delta sync for both backup and restore. Now let's look at our target application again and see if we can see our page that we created. So let's go to the first Blogger application. Let me select here. And first, let's look at the workloads. So we can see everything is up. So let's go back to the services and let's connect to the application. And we can see the application is up. And yes, we can see the new page that we created. Everything's looking good. Let's try to log into the admin interface again just to make sure we can go in and check everything is correct there as well. And yes, we can see our page and everything is fine. Now let's take a look at the second app too. Though we didn't do change there, but it should be up and running just fine. Let's connect to its service endpoint, and yes, we can see that it's running perfectly fine. Now let's go back to Swift and let's do the failover now. So if you go to the DR policies, you can see all the operations it has done. So we have two applications that are syncing as part of this policy, and they are in the same level 0. So they synced in parallel, they were run in parallel. The one of them was pretty fast because it doesn't really have data. It's a stateless app. So it was backed up as well as restored almost instantaneously. And it's working fine. And if you click on any of these, so you'll see all the events like when they were synced, like event history for backup, event history for restore. Also, we should be able to go and check our backups now. So we'll see new backups created there, the incremental backups, two syncs ran. So we see two backups. Similarly, for the other app, you can see that it has one backup created. Now, let's go to DR policy and let's do the failover now. Now, depending on how you prefer to configure the DR policies, you may have one policy syncing all of your clusters. So you'll do failover just for this policy, or you may have one policy per cluster. So it comes to the administration preferences. If all the clusters share the same scheduling config and they sync the same way, then they all can be put under the same policy. So you'll just have a single failover button. Now, when you come to failover, this is where you failover. So you can select a particular app. You can do the entire failover. Now let's do the drill failover. And this is the ordered level order policy. So it's going to honor the one last thing as part of failover. It's going to check everything it has backed up is already restored to the target, because at this stage, it's not going to assume source is reachable. So it's not going to try to do a new backup. It will do the failover. Now, the difference between drill and non-drill is it will keep doing backups because it understands it still has access to the production. So it will maintain your RPO. Non-drill is really it just assumes production is gone. So it just talks to only target cluster. In this case, it's gonna be instantaneous failover because there is nothing running there. As you can see, policy failover because it already has everything restored just now, so everything is up and running. There is no outstanding change, and there is a way you can force resync if you want as part of these real failovers. And this failover will also create your DR clusters if you ask it to do. So you can create backup only policies and failover them, and it will create your DR clusters into Oracle side and then restore the applications. And we can go back and check, like, the applications are still up and running, everything is looking good. So no issues there. So there's no impact. And production right now will be up and running because it just doesn't assume anything for production in case of failure, whether it's a drill or not. And similarly, you can do fallback when you're ready. Now you do have option to force sync there, but for drill, obviously that's not expected. So it's not gonna do that by default. And fallback will be instantaneous too. This is useful even in drill if you are provisioning DR clusters. So when you do fallback, it will go back to regular forward and backup and restore, as well as it will delete any DR cluster that it had provisioned. You have option to skip them, but it can skip those. That's all we wanted to show in this demo. So we set up two production clusters. We have looked at one DR cluster. We set up a DR policy. We did one initial sync through the policy, and then we did some application changes. We looked at delta sync. We checked the application again on the target. It was restored correctly. Looked at the backup as well as how you can do the individual failover for clusters as well as batch failover. Hope that's useful. Thank you.